Hey there, in this clip we're going to be talking about computer metrics, specifically capacity. Okay, so we're going to talk about how we measure something as far as computers go, and that topic that we're going to talk about is capacity. We'll get into defining and explaining what that means. And we'll also have some examples. So at the end you should have an idea of how to talk about capacity when it comes to computers. All right, so we've got signals and storage capacity to we have to unite those two ideas in your brain, and so hopefully this will help clarify that, right? So we know that computers are electronic devices, right? And they use electricity to that end. That's what makes them electronic. They use electricity to operate, meaning just to even work, turn on and do their thing, right? Make their noises, do whatever it is they're going to do. So specifically, what are they going to do with that electricity? Well, one of the key things that they do is they make signals, they store signals, they receive signals, and they send signals. That's the key thing that they do with electricity. Now, the signals that they're making, storing, receiving, and sending, those signals can either be on, which is usually represented with an 1, or an off, which can be represented with a 0. Okay, the key piece is that they have an on state and an off state. Now, here's an example of data. Now, data means that that's what some people might say it's information, but it's data at the very basic. It's the actual, all the signals that are coming in or they're being stored or being sent or received, right? So in this case, we have the red line represents the electrical charge. So when the red line goes up, as in this first part right here, that means it's on, and then it drops down, it's off, off, and then it goes on, off, on, and it finishes with off, right? So that's the data there. So on the right there, you see all those on and off signals. That's a representation of a ton of data there. Now, if you've got all those signals, well, they're going to take up space because they're likely going to be stored or used at some point. So you need to hold them and put them somewhere, right? We're not going to get into how or where they're being stored. Let's just think about the issue and the problem of, okay, well, these things have to be stored and they're going to take up space. So that space that they take up, the fancy word that we use is capacity. So capacity is the measurement of how many on or off signals a computer can store. Okay, so if someone were to tell you, hey, what's that computer's capacity? What they're referring to is how many ones or zeros, how many on or off symbols or signals can a computer store. Right? So again, capacity refers to how many on or off signals a computer could store. So let's break that down a little further. If we already said that a signal could be either on or off, well, then let's take a look at some vocabulary that is also used with that. So here we have our data, and I covered up the other symbols or the signals for right now. But if we only have one signal or a symbol, like in this case, we have the symbol 1, which represents on, but it could be off. Okay, but when we're only talking about one symbol, which is a very basic, we call that a bit, B-I-T. So one signal by itself, one symbol, is called a bit, right? Now, if we have four symbols, we call that group of 4, we call it a nibble. All right, so that's a very specific word, a nibble. A nibble refers to 4 symbols. They don't have to match what I have here. It doesn't have to be on, off, on all the time. It could be off, 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 off. So as long as there's 4 symbols, then we call that a nibble. It could be on, on. That would be 4 symbols again. As long as you have 4 symbols, it's called a nibble. So a group of 4 symbols, 4 binary bits, is called a nibble. If instead we have 8 bits, right, because we said each symbol is a bit. If we have 8 symbols, we call that a byte. So here's an example of one possible byte. Depending on how you flick the switches on or off, right? As long as you have 8 on or off symbols, we call that a byte. So let's kind of summarize that there. If we have one symbol, we call that a bit. An example, off or on. Both of these are bits. If you want to imagine something, imagine a cookie, and it's a very, very, very little tiny piece. Got broken off, that's a bit. Okay. 4 symbols, we call that a nibble. Here are examples of nibbles. So there's 4 symbols here, there's 4, 4, 4. Each one of these is a separate nibble. All right, so it's almost like a little bit more of that cookie. However, if you've got 8 symbols, we call that a byte, B-Y-T-E. And here are examples of bytes. These are not the only ones, right? There's different combinations, but these are just 3 examples there. And that would be a bigger chunk, right, of data that we're talking about. Okay, so now let's look at a topic that we're going to build on. So we kind of have in our head some idea of like these other words that are used, bit, nibble, and byte. But we're going to have to use some other prefixes that exist just in units of measurement. So these prefixes, these words or part of words exist outside of computing, right? Just the area of computers and capacity use these to build upon how these measurements should be used. In other words, kilo, you've used that prefix before, right? Like kilometer, right? Kilogram. So what does kilo or kilo mean? It refers to 1,000, right? 10 to the third, so 1,000. Mega, whenever you hear that, that refers to million. One way to remember that is if you have heard the lottery, like Mega Millions, that's kind of like millions. So mega is a million, right? So it looks like that. We've got 6 zeros over here. So giga is a way of saying a billion. Tera is a trillion. And peta is quadrillion. All right. So these are important because we're going to end up joining these prefixes with those words that we were talking about before this. All right. So this is what it's going to look like when we join these prefixes with those terms that we just talked about. So we talk about a computer's capacity, right? It goes up. So here we've got some pictures, right, showing kilobyte all the way down here, and terabyte is up here. And again, we're referring to how many ones and zeros, how many signals a computer can store. So if we're talking about a byte, if you recall a byte, 1 byte is 8 ones and zeros. It could be different combinations. So what can you do with 1 byte? You could represent 1 letter in the alphabet. That's an example of what you could do with 1 byte. So you need a whole bunch of, 8 ones and zeros to help you represent 1 letter in the alphabet. What about if you had only 1 kilobyte? What can you do with 1 kilobyte? Well, you could fill up about a page of words and letters. All right. So kilobyte, it's about a page of words and letters. How about a megabyte? So if you had 8 million, so notice we're joining here, 8, that byte is 8 million, because mega, remember, it's million. 8 million ones and zeros. What can you do with that? You could take those and represent about 10 large photos, 10 minutes of music, or 1 minute of video. All right, there's rough estimates. What if you have 1 gigabyte? So again, byte is 8. Giga means billion. So 8 times a billion is 8 billion. What if you had 8 billion ones and zeros? Well, you could represent an entire film or a movie, right? That's how many ones and zeros is required to make that possible. So what does a byte look like? So here I'm just trying to give you an idea of a byte. There's a byte, right? There's 1, 2, 3, 4, 5, 6, 7, 8 signals. Now, what does a kilobyte look like? Remember, a kilobyte is 1,000. I'm sorry, 8,000. So kilo is 1,000. Byte is 8. So we're talking about 8 times 1,000. 8,000 signals. That's what 8,000 signals look like. That's roughly, as we said, about if you typed up 1 paper, right? 1 report that's 1 page long of letters and words. Let's say you had an English report and you only filled out 1 page. If you converted all of your letters and everything you typed into bits, that's what it would look like when you break them down. All right. Okay, so it is in summary. So what's capacity? Capacity refers to the measurement of how many on or off signals a computer can store. What is a bit? A bit is 1 on or off symbol. So by itself, a bit is either just an on or an off symbol. What's a nibble? That's just 4 of them. So if you got 4 symbols, on, off, on, off, on, off, so 4 of them, in any combination, we call that a nibble. If we have 8 on or off symbols, we call that a byte. Now, what does kilo mean? Kilo means 1,000. So if you combine that with a byte, if you recall up here, byte is 8. So 8 times 1,000, that gives us 8,000 bits. Mega means million, so megabytes is 1,000,000 times 8. That's 8 million bits. Giga is a billion, so gigabyte, right, is 8 billion bits. Tera, we're climbing up here. Tera is a trillion, so tera is 8 trillion bits, and peta is a quadrillion. So that's a quadrillion bits. Hopefully this helped you understand and get an overview of capacity and how it's measured in computers, so that when you hear these words, petabytes, terabytes, gigabytes, megabytes, kilobytes, bits, nibble, byte, you have a better understanding of what they represent and how many on or off signals we are talking about.